we now discuss the solution of a problem from the section Differential Calculus. This question is on an indeterminate form. This question has appeared in the Joint Entrance Examination Main held on 25th June 2022 in the second shift. The given question is limit x tends to pi by 2 in brackets tan square x in brackets 2 sin square x plus 3 sin x plus 4 whole to the power of 1 by 2 minus sin square x plus 6 sin x plus 2 whole to the power of 1 by 2 bracket close is equal to. We are given four options. Option A 1 by 12, option B minus 1 by 18, option C minus 1 by 12, option D 1 by 6. Required to find the limit x tends to pi by 2 of this expression, this big expression from these given four options. That is the given question. Let's now discuss the solution of the problem in detail. Let's call this big expression limit x tends to pi by 2 of this expression as the expression 1. We notice that tan square x tends to infinity as x tends to pi by 2. Also 2 sin square x plus 3 sin x plus 4 tends to 9 as x tends to infinity to the power of 1 by 2, that will be 3, minus sin square x plus 6 sin x plus 2 whole to the power of 1 by 2 will tend to root of 9, that is 3. So what we observe is as x tends to pi by 2, this will be infinity multiplied by 3 minus 3, that is 0. That is infinity multiplied by 0, which is an indeterminate form. So this will tend to 3. The next bracket also tends to 3 as x tends to pi by 2. So therefore, this expression 1 leads to the form infinity multiplied by 0, that is 3 minus 3, 0 form, which is an indeterminate form. So to evaluate this limit, what we do is multiply and divide by this expression with a plus sign, that is 2 sin square x plus 3 sin x plus 4 whole to the power of 1 by 2 plus sin square x plus 6 sin x plus 2 whole to the power of 1 by 2. Multiply and divide by limit x tends to pi by 2, that big expression, and multiply and divide by the same factors. Now what we see in the numerator, this is a minus b into a plus b when multiplied a square minus b square. When you square it, this 1 by 2 will go away. This limit x tends to pi by 2 tan square x into 2 sin square x plus 3 sin x plus 4 minus in brackets sin square x plus 6 sin x plus 2 by the denominator remain the same. We continue in the next slide. This is what we have done so far. Now 2 sin in the numerator 2 sin square x minus sin square x is sin square x. 3 sin x minus 6 sin x is minus 3 sin x. Plus 4 minus 2 is plus 2. So numerator limit x tends to pi by 2 tan square x into the numerator we have done, and the denominator remain the same. The numerator can be factorized, that is sin x minus 1 into sin x minus 2, and we write tan square x as sin square x by cos square x. Limit x tends to pi by 2 sin square x by cos square x. The numerator is factorized as sin x minus 1 into sin x minus 2 by the denominator as it is. Now what we observe is limit x tends to pi by 2 sin square x is not 0. sin x minus 2 is not 0. The denominator is not 0. But whereas as x tends to pi by 2, sin x minus 1 is 0, cos square x is 0. So we write limit of the product is equal to product of their limits. So limit x tends to pi by 2, sin square x into sin x minus 2 by the denominator. These are all the factors which are not 0 as x tends to pi by 2. And we have separated those factors which are tending to 0 as x tends to pi by 2. So this will tend to, the numerator tend to 0, the denominator tend to 0. So that means we observe this is a 0 by 0 form. So this can be evaluated. Sin square x as x tends to pi by 2 is 1. Sin x minus 2 as x tends to pi by 2 is 1 minus 2. The denominator is 3 plus 3. That is 1 into minus 1 by 3 plus 3 into limit x tends to pi by 2 of sin x minus 1 by cos square x. This is 0 by 0 form. That evaluation I will show you in the snippet. Limit x tends to pi by 2 sin x minus 1 by cos square x. This is 0 by 0 form. Use L'Hopital's rule. Then what we get is this is equal to limit x tends to pi by 2. Derivative of sin x minus 1 is cos x by the derivative of the denominator is minus 2 cos x sin x, because derivative of cos x is minus sin x. Agreed. Agreed. This minus we have taken out. Limit x tends to pi by 2 cos x by sin 2x we have written. And as x tends to pi by 2, cos pi by 2 is 0, sin pi is 0, 0 by 0 form. Use again L'Hopital's rule. That is equal to minus limit x tends to pi by 2. The derivative of cos x is minus sin x. The derivative of sin 2x is 2 cos 2x. Now as x tends to pi by 2, sin pi by 2 is 1. This is minus, sin pi by 2 by 2 times cos 2 into pi by 2, that is cos pi. And this is sin pi by 2 is 1 by 2, cos pi is minus 1. Therefore, it is minus 1 by 2. So, for this, let's go back here. Limit x tends to pi by 2, sin x minus 1 by cos square x. We write minus 1 by 2. So, minus 1 by 6 into minus 1 by 2, that is 1 by 12. Let's look at our options. Our answer 1 by 12 appears against option A. So, the answer to this question is option A. That is the detailed discussion of the solution of the problem on a given indeterminate form. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.